Aliens are coming in November in a ship larger than Manhattan. This time, those are not some of my clickbait video titles. I promise, those headlines are based on an actual claim made by an astrophysicist, Avi Loeb, former chair of Harvard's astronomy department. And he really thinks that an interstellar object called ThreeIATLAS is an alien probe. Based on its current trajectory, it really could pass near Earth this November. So is this it? Are we finally on the brink of first contact? Or total annihilation, just like in Hollywood movies? Now, before we send in Will Smith to destroy the alien mothership, let's find out, are those really aliens? And what an actual probe from an advanced civilization should really look like? ThreeIATLAS wasn't supposed to turn heads. It was discovered on July 1st, 2025 by the Atlas Survey. It's basically our early warning system for potentially dangerous asteroids. Astronomers rushed to check if it could hit Earth, and the trajectory of the object stunned them. It was hyperbolic, meaning it wasn't looping around the sun like some comet would. It was passing through. That made this rock the third interstellar object we've ever seen after Oumuamua and Borisov. But ThreeIATLAS came with a few red flags. See, unlike most comets that dive into the solar system at odd angles, ThreeIATLAS arrived along a plane almost perfectly aligned with the ecliptic, the flat orbital path of all the major planets. It was also moving retrograde, opposite the planet's direction of travel. That alone makes interception or observation trickier, but then came the kicker. Its path would take it within close range, not one, not two, but three major planets: Mars, Venus, and Jupiter. Avi Loeb and his co-authors ran the numbers. The probability of such close planetary encounters happening by chance, less than 0.005%. So their conclusion is, this trajectory overall is totally deliberate. If we sent a probe to another star system, we would probably try to do something very similar to study as many exoplanets as possible. Moreover, we already did essentially the same thing with the Voyager probes, one of which flew by 4 gas giants in one go. In that regard, the trajectory of ThreeIATLAS is also suspiciously efficient. Its velocity, about 60 kilometers per second as it enters and exits, lines up precisely for gravitational assists, or even possible deceleration. Loeb argues that ThreeIATLAS can totally do a reverse solar O-berth maneuver, where a spacecraft fires its engines at the perihelion, its closest point to the sun, to drastically change its orbit and stay in the solar system instead of leaving it. And conveniently, when ThreeIATLAS hits perihelion on October 29th, it'll be hidden behind the sun from Earth's view. Ooh, sneaky. Loeb suggests that could be the perfect moment for an alien probe to slow down and maybe even approach Earth by late November. Oh, and by the way, this object is huge. Estimates suggest it's around 20 kilometers in diameter, which is enormous by interstellar standards. That's at least 2 orders of magnitude larger than Oumuamua. If it's a natural object, it's an unusually big one to have drifted here randomly. If it's artificial, then it's built like a dreadnought. So why aren't governments bracing for alien arrival? Well, it seems that Avi Loeb's paper perhaps has a bit more wishful thinking than science. More recent observations show that ThreeIATLAS has a coma and a dust tail, both telltale signs of outgassing as it warms near the sun. Its spectrum matches carbon-rich ices, not alien alloys or spacecraft surfaces. Loeb still argues that the composition isn't consistent with comets, but well, this one is literally out of this world, meaning out of our solar system, and actually should be different. And that unusual trajectory, it might not be a cosmic plot after all. Some researchers pointed out that our telescopes are biased. We're more likely to detect interstellar objects if they pass through the ecliptic plane, near the inner planets and from certain directions, like near the galactic center. In layman's terms, we're just very good at finding stuff in the area where we found ThreeIATLAS. And when in late October, it won't fire its engines, but instead gains an even bigger cometary tail, we'll know for sure it's not aliens, just a natural interstellar comet flying in from the deep freeze between the stars, albeit with quite a dramatic entrance with its peculiar trajectory. Also, the engineers of an alien interstellar probe probably wouldn't cover its surface with volatiles to mimic a comet, so we'll have a chance to see and study this thing. Aliens would most likely make their probe as stealthy as possible while giving it a peculiar, unnatural form according to their designs, and we wouldn't even know it was coming. Even without visible exhaust, this probe still would be able to change speed for course correction, and that is exactly what we saw some 8 years ago. Yes, I'm talking about Oumuamua, our OG interstellar guest, and compared to its features, ThreeIATLAS looks almost ordinary. Back in October 2017, a telescope in Hawaii called Pan-STARRS picked up something strange streaking through the solar system. At first, it was just a faint dot, but as astronomers tracked its motion, one thing became clear. It wasn't from anywhere around here. It came from above the ecliptic plane and was bound to exit the solar system after approaching the sun. Scientists named it Oumuamua, a Hawaiian word meaning scout or messenger from afar. Quite an unfitting name for something that's supposed to be just a dead rock from deep space, don't you think? But was it a comet or an asteroid? For one, it had a really weird shape. Its brightness fluctuated rapidly, which suggested it was an elongated object tumbling end over end as if spinning out of control. From those changes in brightness, researchers tried to model its shape and got two wildly strange and wildly different possibilities. Either a long, thin cigar at least 200 meters long and 20 meters wide, or a big, flat pancake spinning like a frisbee. Neither geometry fits anything we've ever seen in space before. There are literally no known asteroids with these features and movement. But then, unlike ThreeIATLAS, Oumuamua definitely didn't gain a visible tail as it approached the sun. It wasn't shedding ice or dust like comets usually do. But then it got even stranger. As it passed the sun, Oumuamua began to show a slight but detectable acceleration, as if something was gently pushing it away. But not gravity, and not ice jets, because again, no tail. Just a faint push of unknown origin that altered its trajectory compared to what we had calculated. And that's when Avi Loeb entered the chat. In a now famous paper, Loeb proposed that Oumuamua might be a light sail, a thin, flat sheet propelled by sunlight, like the solar sails we dream of building for interstellar probes. He argued that the object was so thin that radiation pressure from the sun could explain its motion. Or alternatively, Oumuamua could have been a proper spaceship, and its systems awoke near our sun for maintenance course correction. In any case, in Loeb's view, it wasn't natural at all, and our academia just failed to see it. After that sick alien burn, scientists around the world scrambled to come up with natural explanations, and a few promising ideas emerged. One of them, hydrogen outgassing. It's possible that Oumuamua wasn't a typical icy comet, but rather an object rich in molecular hydrogen. Hydrogen is nearly invisible in space, and its outgassing wouldn't leave a visible tail, but it could still produce a small acceleration. They even coined a new term, dark comet, specifically for Oumuamua. Spooky name, and kind of cool if you ask me. Another theory, the strange shape and motion might come from fractured nitrogen or carbon-rich ices broken off from the crust of a Pluto-like planet in another solar system. These shards could form elongated or flattened shapes and have odd reflective properties that explain the brightness changes. So where does that leave us? Oumuamua is still weird and still the subject of debate. But in the years since its brief visit, the consensus has leaned firmly towards natural origin. Strange, yes, but not engineered. The exotic spacecraft explanation now seems less likely than the messy, chaotic chemistry of the universe. But we'll never know for sure since Oumuamua is long gone and we didn't have a chance to send a mission to photograph it properly. And that bitter note led me to the question, so if one day we really encounter an alien interstellar probe, what will it really look like? Not in sci-fi, but in actual telescope data we're able to gather. What would be enough to finally say, yes, this isn't a rock, this was engineered? Let's imagine, or rather, scientifically project it together. It all began as just another automated alert, flagged sometime in 2027 by the Vera-C-Rubin Observatory in Chile. A fast-moving object had entered the solar system from an interstellar trajectory, moving at a whopping 81 kilometers per second. At first, no one gave it much attention. Its estimated diameter was only about 100 meters. It's even less than Oumuamua, and quite unremarkable. Its orbit was similar too, hyperbolic, inbound from deep space at a steep angle and aimed towards the inner solar system. The International Astronomical Union named the object 7I Helena, meaning we were dealing with interstellar business as usual. Probably a small asteroid, a bit elongated, but nothing too fancy. But then the anomalies began. First, its reflectivity. Helena was much brighter than it should have been. Its albedo exceeded 0.9, suggesting a surface smoother and more reflective than any comet or asteroid we'd ever cataloged before. And yet, it emitted no measurable heat. Infrared telescopes, even those tuned for faint thermal signatures like the James Webb, detected virtually nothing. Helena also wasn't heating up as it fell towards the sun. Instead, it stayed cold, far too cold, like a mirror. And while scientists scrambled yet again to come up with plausible explanations, like perhaps a piece of metal-rich exoplanet, Helena's motion changed. Natural objects tumble, just like Oumuamua, especially after millions of years in space. But this one began to stabilize. Its spin decelerated gradually, then locked into a fixed orientation with respect to the sun. And shortly after that, its trajectory began to curve, subtly, but undeniably. The deviation wasn't chaotic, like what we'd expect from sublimating gases. It was precise, the kind of shift caused by solar radiation pressure acting on a structure designed to catch light like wind, a solar sail. Avi Loeb published another paper with claims of an alien probe, but skeptics still weren't convinced. In 3 weeks, Helena reached its perihelion, quite close to the sun. It slipped behind the solar disk and vanished from Earth-based view, just like ThreeIATLAS did. but not from all instruments. The Parker Solar Probe and the SOHO satellite, both near the L1 point, continued tracking it. What they saw didn't resemble any natural object. Its silhouette was thin, symmetrical, and stable. No outbursts, no thermal anomalies, just a sleek disk passing cleanly through one of the most hostile environments in the solar system. And then it accelerated again. On the outbound leg, it was clocked at over 100 kilometers per second, and its new trajectory wasn't random. It was shifting across the ecliptic, veering away from the sun and out towards the Vela constellation. That's when it happened. A single nanosecond laser pulse struck the Allen Telescope Array, narrow band, and precisely aligned with Helena's location at that moment. It didn't contain any obvious structure, and it didn't repeat. But it also wasn't natural. It was a deliberate one-time emission. Whatever it was enough. In a press release that would go viral within minutes, a senior analyst at SETI, the Communication with Extraterrestrial Intelligence Project, summed it up with an eerie statement. It's now considered highly likely Helena was an engineered probe of extraterrestrial origins. It also knew we were watching and sent us a message. The message's contents are currently indecipherable. And by the time top cryptographers confirmed it 100 times with all sorts of AI analysis, Helena was long gone. It never slowed or changed course to approach Earth. It didn't approach Earth. It simply wasn't Helena's mission. The mission was to use our sun for a slingshot maneuver and leave for whatever system it was really aimed at. And the most unsettling part was that Helena's so-called greeting to us was basically just noise. It either knew we were here but didn't bother to speak, or didn't, and it was just an automated probing, like aliens poking our planet with a stick to see if something moves. So, do we now try sending radio signals to Helena's possible point of origin, or sit in complete silence in hopes that its advanced creators never detected our satellites, since, it could be a trap for young, naive civilizations according to the dark forest hypothesis? If you think this scenario of a real alien flyby is creepy, wait till I give you the other one, the one where our alien visitor gets to stay. It arrived just after the new year of 2033, first noticed by a small telescope array in southern Argentina. The object was inbound, fast, and on a hyperbolic path, just like the others. Its temporary designation was, this. Estimated size, 10 kilometers. Speed, in the tens of kilometers per second, just like ThreeIATLAS. It came in from the direction of the galactic plane, just a few degrees above the ecliptic, and for the first few days it looked like yet another interstellar comet. We even saw its surface starting to evaporate and outgas, but not that much, which raised a couple of eyebrows. And then the object suddenly did exactly what Avi Loeb predicted for ThreeIATLAS in October 2025. As it neared the sun, it began to decelerate, not from gravity, not from outgassing. This was controlled, deliberate braking, executed precisely at perihelion, the most efficient point to change trajectory using minimal energy. A reverse Oberth maneuver that dropped the object into a stable orbit around our sun. And then it turned yet again. Our telescopes caught it heading for 16 Psyche, one of the largest metallic asteroids in our solar system, a rock with exposed nickel, iron, and rare elements. NASA had already planned a mission there, but this object, whatever it was, got there first in a matter of days. No signals to Earth this time. It entered orbit around Psyche, locked into position, and then disappeared. Most scientists were virtually paralyzed by this phenomenon, to put it lightly. Almost no one wanted to speak out on how incredibly alien it looked, but it did. Avi Loeb's team put out a new paper the fastest. It was most likely the real core of an old comet or icy asteroid with some machinery built into it. We actually already have space engineering concepts like this. At this point, the International Astronomical Union designated the original craft 13I Erebus, a name pulled from myth. Not a god of war or light, but the ancient chaos that filled the darkness between worlds. And while scientists were struggling to admit the obvious implications of an alien probe disappearing into the asteroid belt, the heat came. Infrared telescopes picked up faint fluctuations on Psyche's surface, rhythmic pulses, radiative signatures of machinery operating in sequence. Next came the launches. Dozens of small objects began leaving Psyche's surface. Some stayed nearby, some moved inward towards Ceres. A few headed for Phobos, the innermost moon of Mars. Their movements were coordinated. And when we ran the trajectories, it became clear they weren't exploring, they were seeding. What we were seeing unmistakably was the arrival of von Neumann probes. Machines designed to survive interstellar travel land on metal-rich objects and begin building more of themselves to replicate using whatever materials they could find and spread out to do it over and over and over again. This concept isn't sci-fi at all. Prominent scientists already proposed that only von Neumann probes would let us truly explore the galaxy using sublight speeds in the span of just tens of millions of years. It's just that with 13I Erebus, we ended up on the receiving end of this process, launched by someone else. The good news is, Earth, with its high gravity and relatively poor metal composition, would be of no interest to these alien von Neumann probes. These machines need light, resource-rich asteroids, and that's it. But on the other hand, 13I Erebus's mission made us feel like ants near a human construction site. We're too puny and irrelevant to them to even bother to contact. At least Helena's creators somewhat acknowledged that we could be listening. These ones, just cold machines, too busy to even take a look at some insignificant ants. And then, all of a sudden, we lost contact with our Mars orbiter. So what do we do then? Do we try to communicate? Try to intervene? If we send a signal, will it be read as curiosity or interference? If we interfere, would that mark us as hostile? And if they have the ability to cross interstellar distances, what would retaliation even look like? Either way, the scariest part here isn't the alien presence itself, it's our irrelevance. That we don't matter at all, not as a threat, not as a partner, not even as a blip. Just one more environment to process. But then, what if these probes aren't leaving for other star systems? Maybe they're here to build some kind of Dyson swarm and extract energy from our sun. You know, the one we also kind of need for life. Another possibility is that they're here to terraform, or rather, alien form some planet of the solar system so that their creators can arrive later to inhabit it. If you're curious how that scenario would really unfold, like this video and leave a comment so I know you're interested. For now, I'll leave you with just that. Yes, one day an interstellar object could really turn out to be alien. And no, whatever it does, fly by or stay, it would be even worse to us than some Hollywood-style invasion. Because most likely, we wouldn't be considered as main characters, more like set decorations, the ones that could be easily removed if they obstruct real actors in the scene. So, how does that make you feel? Share your existential dread in the comments.